afternoon. Thanks everybody for coming. I would like as well to thanks especially Professor Data, conference chair, for inviting me here. And what I will be talking about is artificial intelligence and where it is going. So, Quo vadis from Latin. Before I start, the first time I was to India was 2013, if I remember well. And I was thinking why it is so easy and why Czech people are understanding so well with the people with India. And actually, one of that might be body talk. If you know, what does it mean by body talk if I say something like that? In India, it means yes, I know. However, in Czech, it means I don't know. So, I'm the great guy who says to everything yes. Where I am from? I'm from the Czech Republic. Czech Republic is a really small country. It has a population about 10 million of people only. It is approximately 6,000 kilometers far from that place. And by the way, especially for the students, we were ranked to be one of the top 10 student cities in the world, according to the QS ranking in 2019. We are as well a relatively safe country, and as well let's say New York Times recommended us as the Brno, that's my city of origin, is the place to visit. It was in 2016. By the way, the word robot comes from the Czech word. It marks manual labor or worker or something like that, and it originates from the sci-fi writer. My university was founded in 1899. It is right now largest technical university in the Czech Republic. Brno is the second largest city in the Czech Republic, and we have as well cooperation with some industrial partners. The size of the university is approximately 23,000 of students. We have 8 faculties and in total 81 study programs. And this is the 6th research center. And in one of the buildings I have my office right now. So, back to the artificial intelligence. Where it started was in 1939 in the last century. In one day, it was predicted in 1931 that one day computers will be below 1,500 kilograms. In that time, or in 1950, Alan Turing had a question whether computers can think. A long time after that question, nothing so much interesting happened. Very interesting key point was in 1997. In that time, IBM computer, it was called Deep Blue, beat Kasparov in chess. It was a breakthrough since until that year it was unbelievable that a computer will win on a professional level such a complex game. In 2011 it was another milestone, and in 2012 started deep learning. Deep learning started a new age of AI, and there are a lot of new applications. In 2016 it was the time when the last table game where dominated people was beaten by AlphaZero algorithms. The next year as well poker, which is a skill game, and computers are dominating even in that games. And there is a question, what will happen in another, let's say, 60 years, and what the situation will be about. Well, the question is, whether the situation regarding AI is realistic or there is a hype around artificial intelligence. Periodically, every 20 years, there are significant hype. In the 1970s, it was expected that we will achieve a computer that is approximately of the same capability as a human brain. It means artificial general intelligence. It is a matter of 3 to 15 years. In 1993, it was predicted it is a matter of next 10 years. In 2002, it was predicted it will be a matter of 20 years. For sure, it will not be that case. And now, or in 2018, it was predicted it will be a matter of 7 to 20 years. The truth is that regarding the AGI, it means artificial general intelligence, the progress is not so much significant. Maybe not even any, or very low. All the approaches that we tried was not successful, unfortunately, and only few limitations were done. Anyway, the deep learning in recent years had a really significant success. When it started was image classification. With the image classification in the recent years, there was networks like AlexNet, VGG, GoogleNet, and so on. The milestone there was ResNet. It was introduced by Microsoft in 2015, and in 2015 it was of a higher accuracy than human capability. From 2015 happened a lot. For example, SANET or FishNets are right now one of the most accurate networks, and they are not being used only just for classification, they are deployed as well for the segmentation task. Just as well, there are some applications through 3D-dimensional segmentation tasks, and the progress regarding to this is not ending, and every year there are introduced new topics. As well, in the 3D segmentation, there were introduced plenty of different kind of networks and architectures, and as well, quite related to deep learning and the success of deep learning is object recognition. In the case of object recognition, there are plenty of algorithms. One of the most known is so far a yellow version 3. However, the track behind that is significant. And in December 2019, it was introduced FishNet. FishNet, as you can see on the figure, has with significantly lower computational requirements, much higher accuracy than most of the algorithms that are right now available for the object detection, and that can do that in real time on a relatively cheap device. So as well, in a couple of months ago, it was introduced a really accurate network, and the progress is not stopping in that case. Another topic that some people will have as well in detail, cooperation presentation regarding neural networks in particular generative adversarial networks. The progress started in 2014 by a good fellow with generating of faces. And right now, in 2019, we are able to generate fake faces. Those people that are depicted here never exist, but they are able to detect that with such details that it is almost unrecognizable that there are any fake image behind that. And in 2019, a couple of months ago, at the main artificial intelligence conference was again introduced a couple of the algorithms that even improved the results that were already presented in 2018. This is one of the cases how to, for example, combine a few faces, how to generate absolutely fake images just by giving a few inputs. And Big Gan, the company, Google, is behind that. It's a really nice progress to show how can be detected generated the accurate values from just limited images. The same is actually with language modeling. In language modeling, in a unsupervised way, we are able to generate data. What you can see is the input. The input was actually taken the name of the conference, and the automatically generated text about the conference is over there. Of course, the numbers is not accurate. The conference will have more than 2,000 experts. Maybe yes, however, I don't know where the neural network got that number. However, the text is relatively well written, with no any obvious grammar mistakes. As well, there is a given the relationship with Indian government, that only what was given is the name of the city and the university. It predicted that this is somehow related to the funding and Indian government, and so on and so on. And the progress regarding to that was as well really significant. Right now, the state of the art is Albert, that was as well introduced in 2019, and in that case, they provided a progress in many, let's say, challenges they are given right now. What is impressive as well is reinforcement learning and application of reinforcement learning to game playing. Dota 2 is one of the game. The company which is behind this research is OpenAI in that case. And you can see there five top human players and 5 artificial intelligence players. What you can see there is age and AI. The age are humans, and this is the what is quite interesting on that everything from scratch was trained just by using training neural networks, or in particular reinforcement learning algorithms to learn the behavior and to compete with people. The reward for that is more than $11 million, so there is a strong motivation for anyone to win. And in April 2019, the neural network won 99.4% in all the games that it played, and it's still getting to be improving. What is quite interesting, that for the training was used 10,000 of CPUs and 1,000 of GPUs for the training, and in simulated time that was used for the training was about 45 years. What you will see on the next slide is that there will be a human player. The human player together with AI player, and what you can notice that the human player will try to hide in the trees to get some advantage. You can see that AI players will notice that and will lose interest to fighting with the close one, human player, and they will try to find the human player hidden in the forest. So let's take a look on that game. Right now, he was just hidden, so they are trying to search for him and to get rid of his advantage to be hidden in that place. And what is impressive of that is that everything from scratch was learned just by self-playing the games and playing a computer with a computer. Similar work was related to DeepMind with their F-star algorithms and playing StarCraft algorithms. In that case, I still don't know why it is not playing, well, unfortunately. Unfortunately, no video for that. However, this is another one case when a really complex strategy game was trained by neural networks and beat it 99.8% of all the human players. And it was said that we can pass passed the Turing test on a StarCraft game. So the deep learning and all the stuff related to deep learning are evolving really rapidly. But what is the future of AI, and how does it compare to the human brain? Is it the same basis of the human brain or not? Well, how it works usually with the data is that we are getting vectors, we are getting arrays, we are getting matrices. In general, all of them are being called tensors. They are then being processed, and again, we are getting a vector, array, matrix, or tensor on its input. However, they are not just only tensor data. There are as well graph data, there are as well tree data structures, for example, text. In case of graph, all of us are internally representing the world using a graphs in our memory. So how we usually do and work with vectors is that we are using so-called embeddings, and we are encoding graphs and trees into the vectors, and then we are processing them. Unfortunately, it means that we are losing information. In case, for example, text, we are using embeddings like Elmo. In graphs, we are using, for example, some kind of random walk approaches for this purpose. However, how do we perceive the world? In case, this is coming from the theory of psychologists. Human internal model seems like a graph. For example, let's say we are talking about the image that is written here. There is some cylinders, some sphere, some cube, and the human internal model and how we store it in our memory is that we have some, let's say, vertices. The vertices have some relations, the relations have some attributes, and using that we are coding that using multigraphs, extended multigraphs with some extended features and descriptions of the relationships. What we can do as a human as well, for example during our sleep, is to do abstractions. The abstractions means that we generalize the knowledge, and by the way, we are much better in generalization when compared to current state-of-the-art algorithms. And for example, we can say that all the metal objects are large when we take a look at the figure. So how the problem solving can be generalized is that we are getting any knowledge. Any knowledge it means a graph. While after processing that, we are taking our current experience, and using the current experience, we are applying that, and we are creating a solution. And solution, as it is again some idea, it means it is some another graph. How we can do that is that we have so-called combinatorial generalization, which is being developed in our prefrontal context. And not much of current AI is able to do that, and definitely it is not able to do that in such a way as human beings, as let's say artificial general intelligence should do that. The motivation why to achieve AGI is really strong. There are definitely risks coming from artificial intelligence. Anyway, in case we will be able to achieve artificial general intelligence, to reach artificial superintelligence is not so a big problem. It is expected it will be much more easier than to reach the part of artificial general intelligence. And we can overcome significantly the scale of that. What we know right now and we can understand is the understanding of brain. A couple of years ago we were involved in a research how to analyze that from the point of view of image analysis and how to understand the parts of the brain and how to reconstruct the brain. There are as well already some models of human brain that was scanned and simulated by IBM company. Anyway, no any reproduction was ever able to do that in such a way that there were self-consciousness about the internalization and independent thinking so far. And regarding to that, all the approaches so far has failed. What is really interesting about this, that our brain and as well the bird's brain evolved more than 300 million of years of separate evolution. We both are coming from a relatively simple brain, really small neocortex, really simple neocortex. This neocortex didn't have any capability of combinatorial generalization. However, what is really impressive and really interesting is that the wiring of the brain, of the human brain, is quite similar to the wiring of the brain of birds. And in our brain, there are parts that are related and similar to reinforcement learning. There are as well areas that are modeling self-awareness. There are parts that are used for memory, automated motor skills, and so on. And if I will be able to run it, unfortunately, video. What was seen on video is that birds can do the combinatorial generalization and how they can solve the problems. Unfortunately, there are some issues that I am not able to run it right away. So, what's the difference between the human brain and AI? Is the efficiency of the human brain is really impressive. It consumes only 20 watts. It's 1 million times more effective than the current state-of-the-art computers. It can store approximately 100 terabytes of memory in a really small place. And the size of that is as well 1 million times smaller than that. When we compare the human brain, for example, the games that are able to play the game, were able to play the games on many thousands of years of simulated training. And what is really impressive, that still there are human players that can win that, and the reason of that is that we are much better than current algorithms in generalization. We can do as well, we are really effective in the planning, and hopefully in the coming years we will come and with better algorithms that can help us with the automation of that. I would like to thank you for your attention, and again, thank you for inviting me here.